Hey, it's Mr. Allred, and we are going to continue working with graphing lines. The equation I have here is 7x equals 3y plus 12, so we're working with linear equations. So I'm going to do this different than the other practice problems. I'm going to start with the intercepts. So I'm going to start with find the x-intercept, and that means let y equal 0. So I'm going to take the equation and I'm going to let 7x equal 3 times 0 plus 12. So I just replaced the y with 0. So I can cross out the 3 times 0 since it's nothing. And now I have 7x equals 12. I'll divide both sides by 7 and I'll get x equals 12 sevenths. So that intercept is the point 12 sevenths 0. Okay, so I've got an x-intercept. Separately, I'm going to find the y-intercept, which means I let x be 0. So I'll go back to the original equation and I'll replace x with 0, so it'll be 7 times 0 equals 3y plus 12. Of course, 7 times 0 is 0. I'll move the 3y over, so it'll be negative 3y equals 12. I'll divide by the negative 3. So it'll be y equals negative 4. So that means the y-intercept is the point 0, negative 4. So let's go ahead and graph those, and then we'll do the other part that we've been doing. So we're going to do this one a little bit backwards. So the y-intercept was 0, negative 4, and the x-intercept is 12 sevenths. Now that's more than 1, not quite 2, so I'm just going to put it right here. Now I don't have a slope to kind of move with, but let's just kind of graph these 2 points, and then know that we are freehanding things, so it may not look great in the end, but let's kind of go back after we have those 2 points and make the line. Let's go back and do the y equals mx plus b form. So let's take what we've got and try and get it in y equals mx plus b. So we're going to take the 7x equals 3y plus 12, and we need to get the y by itself. So we can do this a little bit backwards. The y is on one side, so let's just move the 12. So we'll subtract 12 from both sides. So it may look a little bit different than usual, but that would leave 7x minus 12 on one side and 3y on the other. And of course, we want y all by itself, so we'll divide by the 3. So what does that give us? It gives us y equals 7/3 x minus 4. So a couple of things we see here. We see the slope, or the m, of 7/3, and we see the y-intercept of negative 4. So the y-intercept matches the same as when we did it the other way, so that's no problem. But let's see, if we go from the y-intercept that we got here and we use the slope, we go up 7. So from negative 5 I'm going to go up 7, and I'm going to go over 3. And I don't think I could have done a better job if I had planned it. It's not perfect, but it looks pretty good. And you can see that using the y-intercept and the slope got us to the same place. So 2 different ways of getting it graphed, but all this information is very important. The x and y intercepts will be very useful even when we don't have lines. The slope is not very useful, or not useful at all, when we don't have lines. So as we move forward into other types of equations or graphs, we'll kind of drop the slope and kind of focus on intercepts and other characteristics.